Alright, so using what we know about our givens, we have a circle X, and we know that XY is 58. We also know the length of our VW, which is a chord of our circle, being 84 units. XY, I should also say, is a radius of our circle. And we know that LX is congruent to XM. They have the same measurements. Those are equal. If we label those pieces in our diagram, let's see how it can help us find the other remaining pieces. So if we start working on finding YZ next. YZ is a chord of the circle. And notice that it has a distance away from the center of XM. That distance is the same as XL, which ends up at another chord here, WV. Well, again, we learned that when chords are equidistant from the center of the circle, that means they're the same distance away from the center, they must be congruent to each other. So if we know the length of WV, we should also know the length of ZY, which would be 84 units. Now, XM is perpendicular to our chord YZ. We know that if we extended XM all the way through to the circumference of our circle, that would represent a radius. When a radius is perpendicular to a chord, it bisects the chord. So if this length is 84, we know that YM would be half of that measurement, and ZM would be the other half. Since our two chords are congruent, and we also have a radius perpendicular to that chord, the same thing would be happening over here. It would be bisected. So this piece would be half of the chord, and this piece would be half of the chord. Well, half of 84 ends up being 42. So we now know 4 of our lengths in our table. We know the length of YM, we know MZ, we know WL, and we know LV. Now let's work on finding our length here, MX. So MX belongs to our right triangle here of XMY. We know 2 side lengths, but we're missing this third. Well, we know the hypotenuse, we know the leg, we're missing another leg. So remember, Pythagorean theorem says the sum of the 2 legs squared is equal to the hypotenuse squared. So we could use that to help us find the length of XM. And so when we start simplifying our Pythagorean theorem, we end up having a length of 40 for XM. We already discussed in the beginning that XM was the same length as LX based on our givens. So if this is 40, this also should be 40. Now we have to work on finding the measurement for arc ZY. So we're trying to find the measurement here. Remember, this is going to be in degrees for the portion of the circumference of the circle. So let's highlight that so it stands out. So we want to ask ourselves, well, what angle creates this as its intercepted arc? Well, we can see that since it's stopping here at y, one part of the angle would be our segment xy, or that's your radius, correct? So what would be the other part that's making this the intercepted arc? That would come from xz, which happens to be another radius of the circle. So again, this is creating the intercepted arc. Well, notice how we're forming some triangles here. In fact, we've got 2 right triangles being formed. We talked about before with our arcs, the measurements of the arc is related to the central angle from where it was intercepted. So if I could figure out this angle measurement here for yxz, that would help me figure out my measurement for the arc zy. Well, yxz is made up of 2 congruent angles, yxm and zxm, because we know from our triangle congruence properties, right? You've got the congruent pi, we could talk about side, 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 because we know the length. This is reflexive, right? This is the same measurement for the radius. We talked about the chords being bisected. So the angles must be congruent because those corresponding parts are congruent. If we focus in on one of the triangles, let's see how we can find the angle measurement. We talked about the angle measurements related to the side ratios. And so let's see, if you're standing here as the reference, this length of ym, 42, is opposite of where you're at. We already talked about how xy is a radius, which represents the hypotenuse of your right triangle here, right? So opposite hypotenuse uses one of our trig functions. That would be our sine function. And so we could focus on using that to help us find the angle because we know what the side ratio is. Well, in order to find the angle, we have to undo the function. So we use inverse operations to do that. So if we have the sine, we're going to use the inverse sign to undo that process. So remember, these will undo, so they'll give you the measurement for angle yxm, and this would be the angle measurement. Now, we have to remember also that it's not just that angle that's making up the intercepted arc. There are two of them. So I need the measurement of yxz in order to get the arc measure for our circle. So whatever this angle measurement is, I still have to double it to find its measurement. So two of those would be about 93 degrees. That's the measurement of the intercepted arc yz for our circle.